3, 2, 1.
Good evening and welcome to the Wednesday, March 12th, 2025 Middle School Building Committee meeting. This meeting will be a hybrid meeting, both in room A15 on Bliss Road and on Zoom. If there's anybody on Zoom who wishes to participate, please make yourself known using the little hand signals or hand waving thing, and Marty will admit you to talk. I'll now open it up for any public comments. Actually, no, let's do a roll call just to make sure everybody who's here. Lynn is here, Armin's here, Marty's here. We have Nicole here, Josh is here. I'm doing voting members. Voting members on the phone? None. Okay, we do have a quorum, so we will proceed. Moving on then to approval of minutes, February 12th, 2025.
I move that we approve February 12th, 2025 meeting minutes.
There's a motion and second.
Second.
Motion and second. Any comments, discussion? Seeing none, I'll call for a vote. Lynn?
Abstain.
Marty?
Yes.
Nicole?
Yes.
Josh?
Yes.
Armin, yes. We have a 4-1 with nobody on the phone. If you do enter any voting member who enters, please make yourself known at the time you enter. Any public comments? Seeing none, we'll move on to, we have correspondence from Greg Link. Greg had sent in correspondence in regards to PV on the property and how we were handling that. Dory, which the response and the original correspondence from Greg were shared to everybody, that the school is being prepped for PV, but what the plan is, or the way it's being staged, is that with the geothermal and the other things we're doing with the school, there will be some rebates coming in post-project from Mass Save, and then it would be the intent that those funds could be used to finish the PV panels on the roof, because it will not be reimbursed from the MSBA. Am I saying that right? Yes. Thank you. All right. New business, schedule update?
Okay, so we have our schedule. Whenever Marty can pull up
Share the screen.
So that schedule's being pulled. There it is. So we are currently on schedule. The design team has sent over the drawings to the two estimators.
Can you hold on one sec? Tom,
Sure.
Are you taking notes, or who's taking notes?
Diane will do it from the recording.
Okay, so I just want to note at 7:04, David. Thank you.
Jeez, called out.
No, we need it for the minute. Just so everybody knows, we need it for the minutes. And when people come on Zoom or enter the room, it's not apparent to Diane, who's reviewing the videos, to do our minutes for us. So sorry about that.
That's okay.
Go ahead, Adam.
All right. So the drawings have gone over to the two estimators. PM&C and AM Fogarty are the two cost estimators who are going to be doing the work on that. And so they currently have the drawings. And we have our reconciliation meetings that are set up for April 7th and 8th. April 7th is going to be kind of going through the reconciliation part of it, where we have the two estimators and ourselves and people from the district getting together just to make sure that the scope all lines up, that cost and quantities, everything ties together so we can actually have a true reconciliation. And then on the 8th, we're going to go through any type of, if there's leftover agenda items left from that day, but we're also going to go through any potential value engineering items on the 8th as well.
So where are we holding those? Are we doing it in person? Are we doing it just hybrid?
Just hybrid.
Okay, so
Yeah.
everybody's going to be on Zoom.
Everybody be on Zoom, yep. And so I know we have, I sent off the invitation to a few of the folks. I think, Marty, you asked me to invite Tom and somebody else. Lynn, I don't know, or Ian, you're here. I don't know if you want to be a part of that as well, or if, Lynn, you want to be a part. Again, these are all day things, so I know everybody else has their, full-time jobs that they're doing, so.
Way to sell it.
Right. But it would be nice if folks from the district could jump in every now and then, or just have it on in the background, and if something comes up that, if we have a specific question on, or I don't know if there's any particular parts when we get the agenda out that you're going to say the town or they should be a part of this piece of it.
What we were thinking of doing, I checked with the consultants, is
Yeah.
we'll talk to the estimators about none of the consultants had any need to go in a specific order.
Okay.
So we'll ask the estimators, but like, we may have mechanical first, we'll have a schedule, and you're really just listening to these two teams of experts talk back and forth about what they saw and quantified, and then they ask our engineers questions about things that they didn't understand. So it's kind of a lot of information, but we'll set up a more specific schedule, and
Yeah.
then you could share that around so
Okay.
people can see it.
So the value engineering, the purpose of value engineering is potentially to bring the project in at a budget that we've sort of forecast and projected,
Yeah,
right?
with the MSBA, yeah.
If there's, and I'm guessing most of the value engineering decisions are fairly straightforward, but there might be some that are more significant or higher stakes, and, to include this or not include that,
Yeah,
or that kind of
absolutely.
thing. If some of those decisions need to come back to the potentially could need to come back to the building committee?
Yep.
And we would have enough time to do that, given when we have to get the schematic design off to the MSBA?
Right, and so that's why, before this meeting started, that's what we were talking about. We're going to have an additional meeting next month.
Yep.
And pushing the regular scheduled meeting on the 9th out to the 16th. So we'll have the meeting on the 16th, and then we'll have another meeting on the 29th to kind of just do a formal vote to submit it to the MSBA. But the second meeting, or the first meeting that month would be, just give enough time for the community to have enough time to look through the estimate and kind of look at what we thought maybe for potential VE items.
I will say that there's sort of different, we've also asked the estimators, we've given them different things that we wanted pricing on that are, so not, VE sounds like cut, but sometimes it's also that we're comparing different things.
Right.
And so there are some things that we'll be able to make decisions on that you won't care about, essentially, where
Yeah.
we're just getting the information we needed.
Yeah.
And then anything that's super consequential, definitely we would go to the committee for if it felt, if it was a change in anything of your expectations of the project, But there's a lot that we will work through with them on that second day to
So
try and.
if we meet on the 16th, there would be time for the building committee to give direction on
Yeah.
any VE decisions.
Yeah.
Yep.
Just a quick note for anybody who wasn't here when we were talking about it, that the meeting we were talking about for the 29th will be at 5:30.
Yes, and so I don't think, Armin, you were in the room. So we talked about not having the meeting on the 9th, only because it's the day after we get the reconciliation,
Right.
those two meetings done, and pushing that meeting out to the 16th
Yeah.
at 6 o'clock. And then we were talking on having a meeting on the 29th, which we know is a school committee meeting as well, but meeting at 5:30, at 5:30
And for a vote?
for a vote. Yep, so it should be a relatively quick meeting unless
Okay.
there's, discussion on, the estimate. But there shouldn't be really any other agenda items on there.
6:30, we can push to 7 if we need to, though.
Okay, thanks.
Other than that, we have the submission due on May 1st, and then there's the MSBA board meeting on June 25th. And that's where we stand with schedule.
So MSBA board would potentially approve the schematic design, and at that point, we would have a full project scope and budget?
Yes. Yep.
That's a very locked-in number with the MSBA at that point in time.
When is the
That usually
review?
gets formalized before the board meeting? Is there back and forth? I'm forgetting the process now, but, right, doesn't MSBA usually call us in kind
Yep.
of a week or so before the board meeting? And
There'll be discussions that
Yeah, the board meeting is just the
involve
official
the
where everybody.
district as far as, the 3011 and what's in each line item of the overall project budget. And then their staff will then bring it to the board with their approval for the board to make a final approval to move forward.
I have one more schedule question.
Yeah, this is the time.
We were waiting to get MSBA approval on the construction manager at risk approach. Has that been secured yet, or is that, we're still
That was
working?
the Inspector General's office, I think we're waiting
Okay.
back from.
She actually sent me back just a couple comments yesterday, so
Okay.
I'm going to respond to those comments and send it back, but no, nothing
You
that
don't-
was.
You don't anticipate any hiccups there?
I don't.
Great, great.
There's going to be a letter to the editor, and a reminder tomorrow asking where the traffic study is. Do we know when that would be done?
I don't think there's a scheduled date as of yet. I think he was, unless it's changed since the last time we talked.
Yeah, I talked to him yesterday.
Oh, you did? Okay.
Yeah, so they're doing the work end of, very soon, they're starting into it, and I was pointing out the schedule and how we wanted to have time for you to hear about that and get the information back prior to the completion of this phase. And they do need time to actually write it up. So they're going to hand us the final written version shortly before your vote, but they'll have a verbal presentation ready to go to the district leadership I believe it's actually right around the time that we're having that first meeting. So what I can do is line up to have us present it to the district ahead of the meeting, and then present an overview of the results at the meeting on the 16th.
And the letter said we're running out of time to do the study while there's traffic. So it sounds like that's happening soon, though, the observation
Yeah,
part. So,
and
okay.
part of they wanted to get peak traffic flow information, and they wanted information from the district that we gave them this week. That was part of that process, so.
So, I mean, I know it's more calendar when we're talking about like peak traffic flow, but like when I was reading the letter, I was like, it kind of discounts methodology. I would think would be taken into account that like there's a levelization of traffic. It's not always going to be peak. It's not always going to be low, and you can't just study the peaks. You got to study the valleys as well to be complete. So it seemed undisciplined to me, the letter trying to do a methodology, but from your perspective, is that part of the study, peaks and valleys, and not just peak?
Greg can speak to this better than we
Yeah,
can, but
yeah.
he would like to do it in late March to get an idea of walkers and bikers so that they can look exactly what you're talking about, get those numbers so that they have them for their study, but then that they, I've got his email up here, that they load their values so that they can, see what the vehicle demand on a poor weather day based
Thank
off
you.
of that
Okay,
data.
yeah.
So that the report can cover both scenarios.
Okay, thank you. That clears it way up for me.
So if I understood right, that they'll be done and be able to present that on April 16th?
They'll be able to verbally
Okay.
present it. They'll
gonna
have
say
the
that's
final
quick.
write-up that's because we were pushing for
Yeah.
that as well, because it's like, well, you guys are going to be weighing and evaluating the numbers and the reconciliation and the project information, so I wanted you to have that information verbally as well.
And then for the 29th, does that have to be completed by the 29th, or is that,
The report,
yeah?
the written report? Yes, well, we're submitting it to the MSBA, so
Okay.
we want it in hand to go into the report.
Okay.
All right.
And just looking out next couple of months, like what does May look like for us?
Let's see here.
Just with the end of the school year and all kinds of events and things, I'm just trying to get a feel for what might be down the road.
Anything on your end that, I mean,
So the things that are consequential to us, there will be a conversation with the MSBA with us looking at the space summary in the district, just going through that prior to them doing the scope and budget agreement, where they talk about what's allowable and what isn't in their funding. Once we have submitted and once it's been approved, there's this phase where we're really trying to make this information as available to the community as possible. And you can begin that before the June board meeting, and you usually have a pretty good sense already whether or not there's a problem with the MSBA, and there usually isn't. So at that point, you can start thinking about how you present the information to the community, and we're available, and we are already, and we'll be working on developing materials that help to communicate the whole design to the community. We typically will start presenting some packages of information so that people will want to understand what it's going to look like. And some of that's more visual or just a study of the section of the site, things like that. So we'll develop that, and we've started already, but we'll keep doing that even after the SD phase is over. And then at some point, I'm sure you'll have communities in the town that want to hear more about it. So then you can start laying out. It gets to the question of when the public vote is
Right.
as well,
Yeah.
which I don't think we've decided, that's not yet been set by the town yet.
No, not yet. I don't
Yeah.
know if you have a thought yet, Lynn.
Yeah, so what I'm hoping to do is bring this group back a couple scenarios for probably the April 16th meeting. And we can discuss that. And then I would love this group to make a recommendation to the select board on what we think the election date should be. But it's looking like September is a possibility, but the more we examine the calendar, we have to decide whether we want the vote before or after town meeting. And it seems like the more standard approach is after town meeting. So that puts us into roughly middle of November. So we have to look at that. So I'll bring back a memo the next meeting laying out some options. And again, I'd like to have a vote to recommend to the select board.
Great.
Marty and I talked briefly about faculty, JWA presenting to faculty before the SD phase is done. And I think, to your point, like the school year ending, you lose a lot of attention. So if there's a public presentation of the schematic design, before summer hits, that's logical. And then maybe afterwards in fall as well.
Yeah, I see that period as we move into April and May, public engagement, circling back with school staff, kind of evaluating that space summary, make sure that we got everything accounted for. Yeah. All right, good to go?
We are good to go. We are moving on to update, schedule, design update.
Okay, so we're going to keep the design update very quick because we've spent a lot of time seeing the plans. So since we last met, again, meeting regularly with the leadership team in the district, we've been reviewing square footages and spaces and being sure everything is accounted for and addressed. We have done some tweaks to the general office admin area based on our security conversation with town officials, looking at how that flow goes, so that slightly changed that area. We have been going through, trying to really look at the space summary relative to MSBA guidelines to be sure each of those categories, and we'll show that further, but that's altered what some spaces are categorized as slightly. We've done some testing of furniture loads in cafeteria and changed the kitchen plan such that the cafeteria space is on target perfectly now. So that did move that wall. Again, some circulation changes based on district preferences for where they wanted doors and not on this floor. Otherwise, this floor has been relatively stable. This plan doesn't show furniture, but in some of these areas, there's specific breakout furniture, and we've explored that. In the next plan, though, next floor, you see there's been a switch here of the social emotional classroom and the staff break room. Flip that around. Some adjustments to the guidance wing to create a circulation around. So we take the plans, review them with our code consultant to be sure that we have appropriate egress and corridors and exits, and have made all those changes. So that's part of why that occurred. And to get these group spaces in that the district wanted. And then we've done some tweaks on custodial bathroom space locations and utility spaces. So no major changes from when we met last time, just trying to be sure everything's on target for the initial requests and goals.
Hey, Tom, you had asked something about support staff and spacing. Did we address that?
I'm sure we did. I'll recall the question.
You were like, there was like 3 admins versus 4, or 4
Yep,
versus
there's
5?
3
Okay.
secretaries. That
Okay,
was the
thank
question.
you.
Yeah, or is that question about the number of
Sorry.
secretaries?
We
Yeah.
did, I talked to Dory and it was addressed.
Yeah.
Thank you. Okay.
So in the next slide, you'll see an overview of, this is, again, going to be kind of high level, but remember when I presented in the PSR the space summary and how that works with the MSBA grant, it's by division of square footage. So you have core academic, special education, art, music, vocational, health, phys ed, et cetera. So it's not just the overall and you get, X amount reimbursed overall. You have to kind of align it to what their expectations for a school of 665 middle schoolers is in Massachusetts and what they're looking for. Though they're going to also consider what programs you're running currently, plus they'll give special consideration to your special needs requests. And every district gets kind of a different adjustment, review of that by DESE. So in comparing where we were by area to where we were at PSR, we're pretty on target because the core academic shifted because we actually brought it increased because we brought in the math and lit lab that hadn't been accounted for previously. There was a classroom adjustment where we actually took from other, which is an unreimbursed category, took our health classrooms and put them back into that category. So that should be generally a good condition. So I expect those to be reimbursed. Special education went up based on our review and shifting around some of our intervention and support spaces and sizing those to the final plan, and that's reviewed by DESE specifically. Art and music has always been high compared to MSBA's standards, so it's an area that the district may get hit a little bit more because you have a very robust music program, but we've always talked about that, and the MSBA will take that into consideration. The auditorium is not shown there, it's shown in other, which has gone down, which is a good change, but that's still accounting for the full auditorium size. Health and phys ed, we did reduce the gym because as we started working through planning, we realized that we were really carrying a full high school with bleacher area, and since we really didn't need that much bleacher, we took that down. And that's, I think, very helpful because that extra beyond 6,000 would not have been reimbursed. So that's an area you've improved in through this phase. Media center, dining, medical are all consistent with where they were before. We did increase guidance. That was because of request for additional group support space in the guidance division, so admin guidance went up a little bit. And then as a whole, other went down, which is very good. So overall, we're lower than we were at PSR, but not by a lot. I think probably all in all, it hasn't changed dramatically from a reimbursement standpoint. And overall in size, it's about where we expect it to be. Nothing has changed dramatically. We still are providing 900 square foot classrooms throughout and meeting, we've consistently met and reviewed a lot of these space sizes with the district. The grossing's a little bit higher than it was, and that's got to do with closet spaces. So for instance, we did allow for a theater arts closet to store for the after-school programs. I'd say in general, we've been a little bit more generous on this project in circulation and storage than some projects I've seen where everybody cuts tight to the bone. So that's something we can still address before this phase is over if we wanted to tighten up a little bit more. And we can also look at how we can kind of really explore, whether some of that might want to just be contributed, assigned to the specific program area. That's allowable too. It won't probably make any difference to the grant process. So all in all, it's pretty good.
When the value engineering process happens, is there attention during that process to spaces that are reimbursable versus spaces that are not reimbursable, or are you looking at it more as just a whole estimate and the whole building?
It's more the latter.
Yeah.
With the
Yeah.
cost estimators, they
Yeah.
don't care at all
Yeah.
about the MSBA reimbursement, so they're
Right.
really looking at materials, and square footage comes into account there just in terms of amount of material that you need. But in terms of what's reimbursed or not, that gets, Colliers and JBWay will do the best we can to identify those items. And then part of it is you just have to wait and see how the negotiation goes with the
It could potentially inform the feedback that we provide, though, right? In terms of like,
Certainly.
if we see, okay.
What we've stated before, what gets difficult is you can't at this point sort of pull something out of the middle of the building,
Right.
So that's where it gets a little trickier. So a lot of the V is about, at PSR, they had exactly the square footage, a little more, and they were applying that number based on estimated costs of other projects like this. So now they'll be looking at same square footage. So we're in good shape on that relative to the estimating process. So it becomes a material choices about, okay, how much epoxy terrazzo do we have in the project? And, is that going to be the difference where we've made different decisions?
All right. Keep going.
Brian is on the phone. We just wanted to share an update on this evolving plan and share some of what went into the estimating set. I believe Brian's here. Oh, maybe he's not. Maybe he wanted us to speak to it. This is just an update, really. So we shared with you a site plan before. There concerns raised were, we shared two options, remember, and there's a preference for the slightly more organic one. So this is kind of a merge of the two, but it's also a simplification overall. So there are a lot of kind of walkways and different tread materials and paths that were explored. So this tried to eliminate a lot of that while retaining the berming and the screening, making a more clear, singular kind of area for the outdoor teaching space, and simplifying some of the benching areas, and removing in these areas some of the complexity of those spaces, including the kind of raised work surface that was shown in the art area. So we believe it's quite a bit simpler, and what we held on here in cost we felt was helpful to the estimating process at this point, to not reduced beyond too much of a point. The next one shows a little bit more of that close up. So in this area, you're taking instead more of a rain garden approach, and then carrying that to this area, which would be a bit more of a bioswale. This is that teaching area we talked about that these two wings can go out to and use as an outdoor classroom. This is the outdoor classroom outside of the art area, with just loose furnishings as opposed to anything built in other than a seating area. And this is a dining area with some loose furnishings that will be included in the site budget. And then this kind of slightly terraced seating area that allows teachers to kind of look down over the entire area. We've pulled the trees away from the building significantly, and have met with this team and the mechanical, electrical, utility team, and with the town regarding utilities to review some of the loading dock and how utilities are arriving at the building. And you'll hear a little bit more about that from the mechanical team.
So on this one, the field is flipped.
The field?
Yeah.
It's just cut off.
Yeah.
It's more of a
It's just a
zoomed in.
close-up.
Oh, okay.
Oh.
I thought it was going the other way, that one. Okay.
Yeah, I know,
So you-
just zooming
It
in.
went
a little bit.
perpendicular to it. Okay,
Yeah,
good.
yeah.
So, we talked a lot about maintenance and our inability to really cover a lot. Is there a lot of plantings on that, or is that mostly the trees?
It's trees and low ground cover that's consistent, that doesn't require, so we've tried to really have this conversation about mowing. So where there's mowing, it's just straight mowing. And then this area here, these areas would not require mowing. Right, so that's more ground cover approach, and that's why this is kind of treated more as a natural landscape and designed for super low maintenance.
So ground cover is nothing we have to
Right.
maintain, it
You
should
wouldn't
be
have to
by
maintain.
naturally.
Yeah, yeah. So they're moving increasingly towards that. And again, this will keep getting revised and worked through DD and CD, but the intent is very much heard to have low maintenance. I'd say the one area that I think, Brian still really wants us to hold in the budget and keep exploring is pavers as opposed to just concrete, and actually thinks it's a better, longer-term maintenance condition, but there's some concern and hesitation, so we want to be sure that we explore that, and we've been talking a lot about the detailing on that. So that is showing that for reasons that I think he feels are really worth exploring with the district rather than cutting at this point. So.
So during the security portion you guys talked about, did the tree cover come up like so close to the school?
In terms of having too many trees near the school?
Yeah, like places to hide. Sorry to think that way, but
No, not with security.
okay.
No.
Did not come up.
No.
Yeah.
We do have to circle back with that security, because you left us with a series of questions relating
Yes.
to security systems, and
Yeah.
so we do have to circle back with that group, so we'll have an
Yeah.
opportunity to talk to them about that, I guess.
And we
Is that-
will continue to,
Yeah.
in every phase.
Yeah.
So,
Okay.
yeah.
All right.
Awesome.
So, moving on, we're going to go into a lengthy discussion with our engineering team. We hope it won't be terribly boring. It felt really important for us to share some of the process. So I wanted to just preface this by saying that what we're doing at this phase, a lot of this is, and will continue to be, an optimization process, particularly now when you're talking about all-electric schools with a higher climate priority in the state and a much more stringent stretch code, rather than just oversizing all your mechanical systems. We try really hard to design such that you're not oversizing and overspending in your operating costs. So that requires a real process. So we've been exploring with them insulation options around the building, window options around the building, all of these types of levers essentially that we can control, that the combination of which will give us, we hope, the right building, and there are cost benefits to different things. So it's required that we have our model, but then the mechanical team builds an energy model just for study purposes to explore different options. So I want to just introduce our team to talk a little bit about the system selection process, run through some of that just so everybody's understanding what we've been working on and how that actually relates, and why you kind of want to hear about it before we get to those VE questions, because you'll see that there's kind of a cost-benefit relationship to some of these choices that we're going to be making. So can you all introduce yourselves?
Yep, I'm Ian Don here with LN Consulting.
And I'm Greg Eastep with LN.
I'm Scott Alexander with LN Consulting. Sorry, my camera's giving me problems.
Okay, you guys, you can take it away and walk us through.
Yeah, so hi everybody. Just wanted to kind of go through the mechanical systems, kind of the basics of design. And then please feel free to speak up if you have any questions as we go through this. Try to keep it kind of short and open it up for questions, I guess, as we go through. So brief overview, the system that we are selecting as a base of design here is a closed-loop geothermal system utilizing water source heat pumps for conditioning the building. As part of that, and with Greg's assistance, we're basically running energy models, and we utilize that in order to obviously do some envelope assistance and make some of those decisions, but also to size the mechanical equipment, generate operational costs, and then one of the big ones is to properly size the geothermal borehole field. And that helps to greatly minimize initial upfront costs. Greg will be able to show you some of that as we get going, to show some of the significant differences that his modeling can basically point out, and why doing it correctly and making these decisions is good to save money, I guess, on the initial costs, as well as to save energy and to make sure the system performs correctly. I guess we can go to the next slide.
I got a question on that slide.
More of the borehole field. What was that?
I got a question on that slide. The last line is the desires to show the geothermal system has the lowest LCC. What do you mean by that? Well, why? I guess specifically, why does it say desire?
Basically to show that we're making the correct decision to utilize this type of system. So that's mostly, that's what that means, basically. Like, we're selecting this, there's a reason we're selecting this, because based on our energy modeling, our past experience, geothermal systems perform extremely well, have low energy consumption, and through the life cycle cost analysis to show that it is beneficial from a life cycle cost standpoint.
So is the intent we're going to contrast this with like air source system? Okay.
Yeah.
So you're proving
So
it.
yeah, so we're proving it. Yeah,
No,
yeah, yeah.
I guess
But no, but if it isn't proven, like, when,
Yeah,
how do we shift and pivot? Right?
That's why I
Yeah.
asked, desire makes it sound like, well, this is what we want to show,
Right, right,
not
right.
what we're
right.
showing. But I think I see what you mean.
I'm with you.
Yeah, the desire is, we want to prove that we're making the right decision, and that everyone here is making the right decision to do this.
And even for me, like, if a different system might be cheaper, but maintenance and everything else is offset. Like, if your team doesn't have to go in and, you know, fix it all the time because you were saying the closed loop, the pumps last X, Y, and, you know, there's really, it's because it's closed, there's really nothing to do, then that decision still becomes a decision. Yes. Yeah. At least for me.
Yeah. And that's correct. And part of geothermal systems, you can keep going, I guess, for the next slide. Part of the geothermal system is that there is an inherent simplicity to the infrastructure portion of it. Basically, a geothermal system consists of the borehole field, which you're seeing here highlighted in blue, or green, sorry. These boreholes are drilled.
Can I stop you there for a second?
Go ahead.
So you said two different things. You said well field and then you said bore field, right? Well to people in this town is going to say that the water can get contaminated versus saying a bore field, I think, which specifies that it's a closed system.
Yeah, and it is a closed system.
I understand that. I'm just,
Yeah.
when we use our vernacular, I just think we need to be careful of not changing what we're saying. If you're saying it's a bore field versus a well, but you're using them interchangeably, people are going to get the wrong idea.
Yeah, and I misspoke.
Okay.
It's a borehole field. It's a closed loop. It's a closed loop borehole with a supply and return pipe, HDPE pipe that's buried in, that's inserted into the borehole, and then filled with a thermally conductive grout, which seals off basically the groundwater from the surface water. And so,
Perfect, thanks.
This is just showing a preliminary layout of where those boreholes would be located. They are piped together in a reverse return configuration. All that just means that we're equalizing flow through the individual boreholes, and then they are brought back into the mechanical room. We have, currently we're planning on multiple loops, 4 loops. What that means is that you're able to isolate an individual loop if there was an issue, and still have the other, say, 3 or however many of the other ones we have operational. So there's a little bit of redundancy there.
Is there redundancy
And
in the
then-
number of loops? Is it like N+1?
Say that again?
Is there a true redundancy in the number of loops? Is there an additional loop compared to the base case?
Not an additional loop, no. We have redundancy, just some additional capacity in the system, but it's the current design, I don't believe, is going to have a full redundancy of 25+%. We might once we get through the full design process, but that may not always be the case. But we're, and then, yeah, so basically the system utilizes a propylene glycol solution, which is the energy transfer medium, and then that is what's utilized, that's piped throughout the facility to the individual water source heat pumps, which will actually heat and cool the facility. So that brings us to the next side. So space conditioning throughout the facility is via water source heat pumps. They utilize a refrigeration cycle to provide heating or cooling, and they have an air coil, so it's an air-based system. All the individual water source heat pumps are connected to the same water loop. And what that means is that any individual heat pump can be in heating mode or cooling mode at any given time, essentially. And that allows energy sharing throughout the facility. So a space that's in heating mode is able to share energy with any space in cooling mode. And it's obviously very efficient to do this. It also gives a lot of flexibility to make sure that we're able to, if you have certain zones that are like a server room, for instance, always in cooling, we're able to take that energy and put it back in the common loop and exchange it during the winter for any other space. The individual spaces will have a thermostat. Local control will be limited, and that can be up to the discretion of the school. You can have a couple degrees up and down, and then there's a dead band between heating and cooling. And all the filters will be MERV 13 filters. So this slide, roof mounted energy recovery units. So this is the pieces of equipment. This is just an example of a ERV that will provide the ventilation air for all spaces in the facility. Current plan is to utilize basically 4 units that are purely ERVs for ventilation. Another ERV will be dedicated to the kitchen, and then we have a couple air handling units that will actually provide heating and cooling for the larger auditorium and gymnasium spaces. Basically, these units have, probably hard to read, but in the very center there, it's an AccuBlock energy recovery core. It's a dual core that basically continually flips airflow to and fro through the core. So essentially it's continuously exchanging energy. And it exchanges both sensible energy and moisture. So heat and moisture is exchanged. These dual cores are extremely efficient. They're like 85+% efficient at exchanging ventilation air, which is why we don't have any conditioning within the units typically. A lot of that can be done at the heat pump itself. And then these would be located on the roof. Maintenance for these is typically filter changes and servicing the fans if they ever fail. But they're pretty low maintenance items. And then this is just kind of a preliminary roof plan of where those units are located. The kind of orangish brown is where the ERVs are located. Basically, we'll have a single ERV dedicated to each wing for ventilation air. And then the ERV on the far right will kind of also do the auditorium, the gymnasium, and all the locker spaces, along with the cafeteria. ERV number, well, it's not number here, but it's number 5, but it's the one that's over the kitchen. It's dedicated to the kitchen to provide ventilation air for the kitchen as well as heating and cooling. And then the 2 air handling units in kind of green and blue there, they have built-in water source heat pumps within them to provide the heating and cooling for the larger spaces. Again, the ventilation air will be provided by a separate ERV, but the actual heating and cooling provided by those, and they have economizer capabilities, which is a requirement.
Ian, can I interrupt real quick? Just on that same roof plan, the areas in gray are our quote-unquote PV-ready areas. So that's to that question you had earlier on about putting PV on later, and so making sure that we have the electrical infrastructure for PV to go in those areas, as well as our structural engineer taking that into account.
Yep, and keeping these units so they're not shading the PV is also important.
And it's a little hard to tell, but just if, what you also can't tell is this is a sloping area and sloping area. So what we're also trying to do is hide these so that they're not visible from the residents aside, and from the front of the school. So trying to be mindful of view.
And then this slide just kind of gives just a little overview of how the air-based system is laid out. So you have a roof-mounted energy recovery unit that has both outdoor air and exhaust air components to it. We have basically every individual zone gets a variable air volume box to control the ventilation air that's either extracted from or delivered to each individual zone. So if you have a classroom, for instance, each classroom gets a water source heat pump. That water source heat pump will completely recirculate the air within that specific classroom, but the ERV will provide outdoor air directly to that zone and extract exhaust air directly from that zone. And then that's individually controlled. So each individual space that has occupants, or like a classroom, for instance, will have a CO2 monitor, and that will control how much ventilation air is being provided there. So CO2 levels rise, the VAV box is open, and move more ventilation air to maintain the CO2 levels in the space. The fans that are within the energy recovery units will then modulate up or down as necessary to kind of maintain it's a static pressure within the ductwork, but that's how they react to the demand. And then, so this is just kind of a picture of what the VAV boxes look like. So they're just a damper with airflow sensors and a damper controller. So they're, again, monitoring the airflow that's going through them. In a classroom, if design airflow is 400 CFM and we need design, these modulate up and they're maintaining 400 CFM of airflow. That was kind of all for me. Unless you guys have any kind of mechanical questions, we can jump over to energy modeling.
I guess the first slide had the bore field. Where is that relative to or on the site plan?
That's up just west of the cafeteria and gymnasium area. In the PSR phase, we were showing it to the front of the school. We've shifted over, and you'll hear that we've reduced the quantity of it as well.
So that's the playing field we see just to the right of the...
Exactly.
Yeah.
So we're staying away from the synthetic turf field, staying out from underneath the building, and trying to get it as close to the mechanical room as possible.
And isn't a lot of that area is paved over? Is that correct?
It's a mixture, yeah. So our basketball courts are kind of in that upper right corner, and then you can see a little bit of the emergency vehicular circulation around the school.
And that's not problematic, having that paved over at all?
No.
It's about, those are about 6 feet below grade anyway, the top level.
Yeah, they're buried about 5 to 6 feet down. Once they're installed, they really don't need to be serviced unless a leak is developed or discovered. Otherwise, they can, they're going to last 50 plus years.
In a larger plan, there's a lot of utilities coming up and then down into the mechanical room, so that was part of why we shifted it that direction.
Are there any kind of limitations of what we can do in the bore field as far as equipment traffic, adding outbuildings, anything like that?
Shouldn't be issues or limitations on that front. One of the biggest ones will be if you guys do future work to understand where the borehole field is, to try not to disturb that. So if you're trying to dig 5 or 6 feet down, you could be running into some of the piping that's there, but there should be some dig safe tape and stuff like that. So that's just something to be aware of, but the earth above it should be able to withstand what's going to actually be driven across it, or what's going to happen there.
All right, thanks, Ian. Good overview. Hey everyone, I'm Greg. I've been working on the model for the last couple of weeks, and specifically the last few days preparing for this. The scope for energy modeling, as I see it for this project, is going to be touching on several different phases and aspects of the project. So the process is going to include an architectural and mechanical design assist of the proposed building. It's going to include a schematic design, utility, incentive report, life cycle cost analysis, and lead documentation. Most of these slides and the images and tables are going to contain a lot of information that is going to be difficult to read and understand in a format like this. Know that all of this stuff is going to be included in the design, the architectural and mechanical design assist is going to be included in the schematic design report, and it'll be all detailed and written up and explained in much more detail than I could go through in a meeting like this. So what you're seeing here on this slide is the the specific school detailed HVAC modeling. I mean, and if you can believe it, every single component of the mechanical system is included in the model. That's from all variable speed pumps, all variable speed fans, water source heat pumps, the ground heat exchanger, absolutely everything. So that is basically what the schematic looks like, showing all the connections and all of the equipment, the ERVs connecting to zone groups, and even the domestic hot water system. And one thing I want to point out, if you go back up to the top of that slide, is that I currently don't have a ground heat exchanger object shown because we're in the process of sizing that right now. So what I have are district objects, and those objects are essentially load gobblers. So depending on the configuration of the architectural system, which is the things that we're varying right now, the load to the ground is changing. So keep in mind that the rest of the mechanical system is fixed for all of the design assist process, but we are taking a look at how it impacts the loads on the ground. Okay, so I've been working with Dory and the architect team to come up with a parametric analysis. And this table here essentially describes and details all of the alternatives or iterations that were done in the parametric analysis. So what you can do is you're allowed to compare two design variables of multiple iterations, and then you can output a variety of output variables to see how the design variables affect the outputs. So what we did was, as you can see on the left, the design variable, the first one was the construction template. Alternative one was essentially the ASHRAE code minimum baseline. And you can see some of the envelope U values and the infiltration metric that was used. And then the next one was the Massachusetts stretch code and the associated envelope values. And then it was JWA's proposed envelope, the one that included 2 inches of underslab installation. And then another one where we recommended that we model and prove that no underslab installation is going to be required. And in fact, we show that it has a very low impact, and it's certainly worth saving the couple $100,000 and removing that component. So those are the 4 construction templates. Now the window templates, there are 6 of them. I was able to get, from the bottom 3, I was able to get some detailed information on some of the glazings that the architect is considering. That's alternative 4, 5, and 6. Alternative 1 was a sample of a triple pane window that I grabbed from my library. You can see it has a low U value, but a fairly high solar heat gain coefficient. The next is what Massachusetts IECC 2021 code requirement window is. And then I threw in a thermochromic window because I've never checked that out before. I still need to spend a little bit more time understanding that alternative. Okay, so basically what we have here is 4 times 6 is 24 possible combinations. So 24 simulations were fired off simultaneously. And if you go to the next slide, you'll see what that data looks like. So we have a big table here. The design variables are the 2 far right columns, and the rest are the output variables that I chose. And the output variables that I chose were mostly focused on to see how the load on the ground was reacting. So I didn't pull out the cooling electric energy and the heating electric energy, but I focused on the lighting energy, which would vary based on the glazing visible transmittance. But what I was most interested in is these district loads. District is basically the name of the object. You can think of that as geothermal cooling load. The kBTU is the annual energy load. And then I calculated a balance ratio, and that's basically when you sum up all of the energy that the ground is either sourcing or whatever the building is projecting or sourcing, you have a ratio. And so that's what that column is. The other 2 are peak, which means your largest demand, your largest cooling demand, or your largest heating demand. Okay, so it's a lot of information here.
And we believe you.
Yeah. And if you want to dig into this or ask questions, you can. It'd probably be best to wait for the report, but I'll try to explain.
David, would you like to ask a question?
I'm absorbing it right now.
Yeah. I mean, it's just a bunch of numbers, but why don't we just go to the next slide, and this will be a sample of, I have two graphs here, which are basically much easier to visualize the results. Each design variable has its own graph. So this is just, some of this is just showing that a whole lot of detailed work is being done, and that I'm working with both Ian and Dory to make sure that your building is optimized. So I think from now on that table and this slide, that's what I want you to know. So you can go down to the next one. Same thing. It's just showing the relationship of all of these alternatives with the various output variables. But I think the next slide is probably the most interesting and the biggest takeaway here. So, of all those alternatives, I grabbed...
Can you hold on one second?
Oh, go ahead.
I would just point out, though, for the public, like, this information is part of the public record and available. I know we have a lot of engineers in town who will definitely...
Geek out.
Yes, exactly. And so, glad to know that this is available in case the public want to see it. Yes. So, thanks. Sorry, I just wanted to make sure that was pointed out.
That's great, and I love discussing this, so hopefully somebody has questions that we can answer, or, sometimes there's interesting phenomena that people don't expect. So of those 24 iterations, I decided to grab 4, as you can see here, and the iteration number just matches with the combination of design variables that were in the previous table. The way I made my decision was I basically sorted by the peak cooling demand, because all of the combinations show that the building is cooling dominant. And then I was noticing the imbalance. And so let's just get to it. Basically, iteration 5 is more or less the best combination, and it resulted in the lowest number of boreholes. So that's a good thing. That means we're saving quite a bit of money by going through this process and finding the right configuration that can reduce the size of the ground heat exchanger. So just looking at this top line, you'll see, okay, we have about a cooling imbalance of 7.4, meaning there's about 7 times more cooling energy rejected to the ground than is sourced. And the driving factor for sizing the borehole was that cooling imbalance. And what that means is I model it out for 30 years, and as the ground warms up, I want to make sure that in 30 years we're still providing reasonable water temperature to the heat pumps. Usually it's about into 80-degree temperature after 30 years. So if it goes above 85, I add more capacity. Okay, and so that iteration included the architect's proposed template without ground slab insulation, and a glazing window KF79N, the planning one, which had a low solar heat gain coefficient. All right, so going to this next one, which was, I just want to talk a little bit more about this table, because the next one is a 50 borehole configuration. So if you go with the package that over-insulates and then under solar heat gain coefficient, which is iteration 16 there, you have a cooling imbalance of 17 times. And then the borehole field goes up to 50, and again, that is driven by this long-term heat accumulation in the ground. So then if you sort of flip the scenario and you go to more or less the least amount of insulation, the ASHRAE 16 baseline, you get really nice balancing on the ground, but then the borehole field has to go back up in size just to meet that first-year heating demand. So the takeaway here is that the architect has a great construction template, and we're going to make sure that the windows have a low solar heat gain coefficient. All right.
So, question about the assumption for like cooling energy demand annualized. Is there a consideration that the building is not in use, at least to the same extent during the summer?
Yeah, that was calculated there as well. So we
Okay.
did gather information on usage, and I think there's actually even a little information might show that, but we gathered and
And the reason I even ask is when we look at the peak heating to peak cooling, they're not so different, but annualized cooling is significantly higher than annualized heating. And I don't really need to get into the why, but it made me
Right.
wonder, like, why are we seeing so much more energy consumption for cooling compared to heating?
when historically it's the other way around.
Right, and the peak demands are not as different. They're not a factor of 7 different. They're, 50% different?
Yep.
That's right. That would be because the peak cooling demand is occurring outside of the summer. It's occurring when the school is occupied, most likely in either August or June, right? So probably the July might be your design day. And the reason that, and you have to remember, these are loads to the ground, so it's more or less the condenser load on the building. So all of the compressor heat and all of the pump heat is also included in the cooling load. So that drives the cooling load up.
Okay.
So essentially hurts the cooling load and helps the heating load, if
Got it.
that makes sense.
Yep, got it.
So the LMS proposed template, number one, that's the construction template. Is that insulated or non-insulated one?
Oh, it's insulated, that's,
The slab, though?
The slab is
No,
not.
no.
Not, that is
Taking that
not
out.
insulated slab.
That is,
Okay.
that is a non-insulated slab.
Okay.
So
And then the
you're
second one is the
definitely recommending
insulated.
to remove the ground floor
Okay,
insulation.
thanks.
Surprised us.
Yeah.
I understand very little of this, but was it the iteration that you're pursuing clear cut, or was it sort of
the
a coin
window,
flip?
the window study was, the window study was the element that was most interesting to us. We were surprised by the slab insulation issue. Because the new stretch code really kind of assumes and encourages a lot of factors, and that's one of those factors that's presumed. And then if you're able to demonstrate modeling that's actually not helpful, that changes your approach. And at this level of building, you have to do a lot of modeling and prove what you're doing to DOER as you're going through it. So they don't want you to just go by rule of thumb. So we go through this, you may start with certain rules of thumb and then work from there. The window, the solar heat gain was the surprise to us, and that's really how you're combining what your shading level within the window is, or how much heat's coming through the window, and how you can control for that with different types of window packages. That was really a huge impact. And that's something that we're still looking at. We're also still looking at shading and the impact shading systems have. Shading systems can be expensive. So all these things are just kind of variables that we want to understand. Because you can throw everything at it, but then not everything's equally valuable.
And when you say slab insulation, you're talking about mitigation of heat transfer through the foundation to the
Yes.
ground?
Yeah.
So we'll still keep insulation at our foundation walls, and for the first 4 feet of the slab, that's really protecting heat loss to the exterior. But once you go past that 4 feet in the middle of the school, there's very little. It's a negative impact to add insulation under there, which
Yeah.
was surprising to us.
That's correct. And in fact, the proposed template includes 4 feet of horizontal perimeter insulation, just to sort of help that, because all the ground transfer is really occurring at the perimeter as opposed to in the center of the building. Okay, so after all of that, I took iteration 5, created an actual closed loop ground heat exchanger object in a software called Ground Loop Design, or GLD. Imported that back into Design Builder for a proper simulation, which means I've removed those district load gobbler objects and put in an actual closed loop ground heat exchanger. I ran iteration 5, so we're showing an EUI of 19.4, which is great. This is still early days. Like, I don't have kitchen information and the floor plan and the usage is still changing, but as of now, we are on target and under target. The target being 25, in case you didn't know that. And then I also modeled the Eversource G3 electricity tariff. That has its own caveats. I have some questions about the tariff. I need to call the utility, but I'm finding about $164,000 per year in OpEx. And these are just a few tables that will be included in the report. There's the energy end use, where it breaks down all of the end uses, and then I just threw in a building area and a window to wall ratio. It's just sort of good checks for the architect to see there. Okay, so this again is just proving basically quality control, that I am looking at everything in detail. Here you can see this is essentially the geothermal loads, red being heat sourced from the ground, blue being heat rejected to the ground, and you can clearly see that the summer is unoccupied and in setback condition there.
We kind of jumped by the OpEx assessment.
Yeah, I was going to say, good. ask, please, because.
Yeah, so this is our operating cost for heating and cooling of the facility, yeah?
It's the entire operating cost, your entire electrical bill.
Okay, including lighting and everything, everything. It's all in? This isn't just
Absolutely.
about the, okay. So.
This is absolutely everything, the full electric kitchen, all of the HVAC, all the plug loads.
I would say we're
all
still at
of it.
SD, and he was working off of, we're in early phase, but
Yeah.
per the modeling guide.
Well, and my question is, OpEx for a comparable facility that is not ground source geothermal, and now I'm talking about total OpEx.
Life cycle analysis, yeah.
Yeah, how does that compare? How does 165 annually compare to, a facility of the same size that's on oil heat or gas heat? Do we know approximately?
Well, I can say that unfortunately in Vermont, where I'm most familiar with these projects, I will show that we'll save over 50% in energy and maybe only 10% to 20% in cost because natural gas is so cheap and electricity is so expensive.
But it's still a net savings of cost, is what you're saying?
Yep, usually a net savings. It helps more if the facility is occupied during the summer. But I will be doing I'm sure I will be doing a fossil fuel system comparison for LEED, if not for the incentive report. So we will eventually have that comparison.
And that will be done before,
The life
the
cycle
April?
analysis, technically, the full life cycle analysis is a DD deliverable. We deliver a version now and then another version when the system's more optimized in DD.
okay.
So you get kind of an assessment along the way. This version, we remember at PSR, we did take the cost of an air source heat pump and a ground source heat pump. So those were based on sort of apples to apples of that. So now we have a more detailed geothermal. We don't have the complete. So we're comparing those and the ASHRAE baseline, as we talked about, and there'll be a report on the comparison of those. But they're still trying to optimize and optimize further. So we're going from that point and getting better and better into DD.
Okay.
So-
And solar throws off all the calculations anyway, right? Because that's a cost, but then that cuts out a lot of our.
Right, that'll reduce further. We're asking for the information on the cost of solar with the cost estimate, and we'll have the positive benefit of the solar production to add in, which will just be added information on top, but we're trying not to use that as part of our life cycle analysis. It'll be incorporated into the report, but because we can't guarantee that you're going to do that after the project's over, we want you to have the information, but we're not relying on that as a part of that. It does, for the mass save incentive, solar, I think it's, the solar does play into the mass save incentive calculation of EY. It does not play into the stretch code energy modeling at all, so.
And if we went any other, well, if we went pure electric, I guess, but if we went other ways of heating and cooling, solar wouldn't even be an option, it wouldn't matter.
Well, you always have electrical use, so, and
yeah, right,
electrical
but-
use for school is always considerable, so.
Like if we had gas
PD
heat.
helps,
Solar wouldn't help with that.
right.
Yeah, I mean, if there's on-site solar, I can certainly model that and include the net metering, and you can see those results. For LEED, that is going to have a big impact. So if you have on-site solar, your LEED points are going to go up pretty significantly. Okay, go to the next. This is my estimate on occupancy. You can see total. I'm assuming total occupancy generally around 750, students and staff. I assumed a monthly event either in the gym or in the auditorium. So that's what those little peaks are. And then you can see summer not being very occupied. Then you can see various holidays. So this just shows you that the schedule is detailed. Go to the next one.
So,
This is the
hold on one
oh, yeah, go
second.
ahead.
Question for Marty. So, we get to school, we've got the geothermal, it's probably cheaper to run than the high school system. Would you consider like moving summer programs there? It'd be cooler, more comfortable.
Might give us some
and
options, yeah.
Would that change the modeling at all?
It would, not in a negative way.
Yes.
I'm going to say, that would impact the model in a positive way, right?
No.
No. Oh, okay.
I mean, yes and no. Your energy
Spoken like an engineer.
is going to go up if you're using it in the summer.
Right.
So if you have heavy summer use, then we're going to start getting close to that 25 number, right? But I think if you use it in the summer, I think the comparison of OpEx to, say, a fossil fuel baseline will start to look even better. Yeah.
So if you're comparing it between the two schools, in a sense.
Yeah, like
right?
if we have to keep the high school open with, which isn't really a air conditioning system, but I don't even know what we call it.
Dehumidification.
Dehumidification system. I mean, that it might be cheaper to do it at the middle school. Right.
I see. Yeah, as far as the cost to operate your system, yeah, moving it into this new top-of-the-line facility would probably be a wise choice. Yeah. All right. The next few are just like other samples of quality control graphs that I include in my report that only the curious engineer types might review. But basically what we're showing here is for a summer week, I think this is actually the first week of school for 2025. We're showing the ground heat exchanger heat transfer rate and the mass flow rate on the top, and then on the bottom we're showing the heat pump loop supply water temperature and mass flow rate. And then here, this is another level of detail. I'm going to look at representative classrooms, and I'm going to take a look at summer and winter weeks to make sure that the performance of the HVAC system is operating as expected. That top graph is just showing the zone temperature. You can see it's between 70 and 75 degrees. When it starts to flatten out at 75 degrees and you go down, you'll see that the zone water source heat pump in the middle graph is kicked on with a cooling load. And then the bottom is the ventilation airflow rate, which is modulating to maintain CO2. So I can also control the model based on those requirements that Ian is specifying in his construction documents. So that's what that is. And then here's a sample of the life cycle cost analysis calculation. If you're curious about how I do it, this is it. It's essentially gathering the annual energy costs and the annual maintenance costs. Then it is gathering the expected equipment replacement costs, and I have to know what the life cycle, what the expected lifespan is of that equipment, and then I also apply an inflation rate to calculate the future cost. And then we usually get the initial total installed cost from the estimators. So that's what that line is. And then the bottom, the life cycle cost analysis, I basically sum up the one-time payments. I sum up the annual operating costs. And then I calculate a USPW, which is a Uniform Series Present Worth Factor. And that's the function of D, a discount rate. I typically, for most these types of calculations, use 5%. And then the number of years, typically 30 years. If there's a standard that it's 40, even better. And then basically what you do is you compare the present worth of all of your alternatives, and you want to choose the lowest present worth.
And this is not our project in numbers. This is just what the analysis will
we
look
are
like.
not ready. We don't
We're not
have
ready.
any of this information. We don't have our proposed system specified fully. So we just thought that you guys might like to see how I plan on calculating that.
And for this hypothetical scenario or this reference scenario, the installed costs for the two cases are not so different. Is that consistent between these?
That's what we expect to see. Ian can speak with more authority than I can, but generally with the incentives for the geothermal systems, we are finding the total, the installed cost to be brought right in line with the sort of air source competitor.
And there's a slide
Yeah, Greg,
about.
right. It's usually with the incentives, they get a lot closer. It might still be a little bit of a premium for geothermal. Once we get hard numbers, we'll be able to get that comparison a little closer. But there are significant incentives for the geothermal system, which helps.
So that initial total installed costs row for the bottom, that's after incentives?
Yes. And that's how we will be trying to calculate the, I think per the very first slide that Ian presented, we're going to be making sure that the incentives are included in the total installed costs.
And the blue case is gas, hot water? Am I reading that right?
Yes, yep, gas, domestic hot water. I believe this was for a multifamily residence campus, so there was a significant domestic hot water load.
Okay. And our two cases would be all electric in either case, is that right?
I think
Yeah.
he said there's also the ASHRAE base, which is not necessarily all electric.
Yeah, I got to get clear on which alternatives need to be included in the life cycle cost analysis. I think it might just be the proposed mechanical systems that the estimator is pricing.
And then we have the information from PSR for the air source heat pump, so they're taking your guidelines for that as well. So that figure you already have. So it's supposed to be air source versus ground source, but then as a part of the stretch code assessment, there's the ASHRAE that is also a reference for some of your decisions. I don't know if you do a full comparison to that, but it's helpful to have some baseline information to contrast.
The projections on the 20-year replacement, is that like as they break down replace, should we plan in advance for that?
Yeah, I'll let Ian speak. He knows more than I do.
I mean, I don't see it any different
Yeah,
than
so-
like ambulance or a fire truck, so I'm just trying to.
Should be, right? I mean, this is,
Sorry,
go ahead.
Ian?
Go ahead.
Ian, can you talk about different parts of the system have different life cycle, life expectancies?
Yeah. Correct, yeah, so basically, water source heat pumps typically have a 20-year lifespan. Obviously, some will last a little longer, so there are plenty of water source heat pumps that have lasted 30-plus years. Industry standards is an expectation of about 20 years. And that's kind of one of the benefits of a geothermal system like this, because there's a lot of individual zones and individual pieces of equipment that are somewhat isolated. You do not need to preventatively replace heat pumps. So a heat pump fails in a particular classroom, it only fails in that classroom. So if that thing was to fail, you either can, some of it can be repairing of a compressor, for instance, but if it comes time to full replacement, that unit would become isolated, the classroom would be shut down for however long it takes them to drop the unit and install a new one. And then the system, then is put back in service. So on individual heat pumps, that's how that operates. The circulator pumps for the facility, see 15 years. Again, there's pumps that have lasted 30, 40 years, but the industry is kind of assuming 15 years on those. But those have redundancy. Any one of those were to fail, you would just swap it out or repair a motor or whatever component. The ERVs and the AHUs are some of the bigger components. They typically have a 20 to 30 year life expectancy as well. The ERVs, realistically, those can just be repaired in place for a lot of their components. The boxes can last over 20 years for sure, and it's really just replacing fans as they were to fail, and then maybe damper blades and perhaps the energy recovery core. And I think, Greg, that air source system was comparing to VRF, if I'm not mistaken, right?
I think this was for Windy Ridge, and I think it was just mini splits.
Yeah, so we've definitely heard that the mini splits have not been lasting, but the VRF systems are different. We're obviously not comparing that here. We'd be comparing to an air to water system, but just as a comparison, you're asking about, do you have to replace the whole system? A VRF system is completely interconnected, which is different than this. The individual components can be replaced on an as-needed basis.
Thanks for hanging in there with me, guys. Basically, the takeaway at this phase of the energy modeling is that we're showing at least a 30% borehole reduction, so that is a significant amount of cost savings. So just by going through our design process, it's going to be better than somebody else who might just go with rule of thumb metrics or just design date calculations and not going through this whole detailed model. And then we've also determined to remove under slab installation. That's going to be another nice initial cost saver. So the first round was the simultaneous architectural and mechanical design assist. Now that we have a more or less have a ground heat exchanger sized, we can continue this process with some more architectural design assist. We can, continue to get into more detailed proposed constructions and proposed glazing and shading. And I'll be able to output more of a EUI numbers and see how that varies in addition to OpEx and see how that varies in addition to some exterior window shading analysis. So that was sort of the simultaneous round one, and then a few more rounds to go to continue to optimize the school. Thank you.
What does gym construction and glazing mean?
Just means that the architect is considering some different types of construction and glazing. Dory, you don't want to let them know.
Sure. So at the gym is the most, and the auditorium, but the gym in particular because of its orientation, location, and the fact that you want this sort of open space, we're looking at the possibility of using structurally insulated panels for the roof. So they come prefabricated. They're both structurally supportive as well as well insulated. And then the possibility then of exposing glulam beams inside rather than just having giant metal trusses. So we're exploring whether that has some advantages and disadvantages and what the impact might be. And then we have different scenarios. The glazing scenario at the gym, and it relates to glazing scenarios elsewhere, is we're looking at a product called Solera, which is one of many translucent insulated panels. Sort of like CalWall, but much better. Not really the same thing. So CalWall are those panels you've seen in those 70s era gyms that you can't see through them, but you can get the daylight from them. So we're looking at a mix of different systems like that in the gym to be sure we get natural light in the gym and don't create glare. And the more natural light we have, the more we can reduce electrical use. So you just want to optimize it. It really takes a long time to. Simultaneously, we have a whole nother team working on daylighting modeling, looking at the value of different approaches on that. We've kind of put a few things in the model and in the cost estimate to explore.
The last slide.
Yeah.
Oh yes, incentives. This is somebody else going to talk.
Greg, just a sec. We have a question here. So hold on.
Could you talk about what happens in 30 to 50 years when the system needs to be replaced? Would it be beneficial to have more boreholes to kind of offset that added cost, or what does that look like? I guess what I'm trying to wonder is when the system needs to be replaced, is it a whole new system? Is it we can use part of it and build out the new system? What does that look like?
Yeah, there would be really no need for full system replacement in, say, 30 years. By 30 years, just going based on historical averages, all of the water source heat pumps will be replaced, but on a, once you start getting out there, you probably have to replace a certain percentage of them each year. But again, some of them can be repaired, some of them are dropped down, put a new one back in. A water source heat pump from one manufacturer to the next is quite similar, the shape of them and configuration. So that's not a huge task to do that. The goal is to have a lot of those located, if not all of them, located within the corridors. So servicing of those is via the corridor space. But no, like the piping will last. It's all copper piping or steel. And with the water, as long as the water is maintained within the system, the water quality, piping should last well beyond 20 to 30 years. The ground source heat exchanger, the base of the borehole field, should last well beyond 30 years. And then again, some of the other components would just be replaced on an as-needed basis, whether that's a fan or a pump. So no, there should be no full system replacement needed.
Hey, Ian. what
Yes.
happens if, say, in 30 years, we're finding that the water is coming back too hot? In other words, the ground heat exchanger is sort of undersized at this spot, at this time. You know, clearly you could add fluid coolers, you could, drill more boreholes, right?
Yep, if additional cooling is required in the long-term future, there are other ways of doing that, whether it's adding boreholes, so you can, if there's sufficient space on the site, an additional loop could be created, or another borehole, a set of boreholes can be created. And as Greg mentioned, there's what's called fluid coolers, or basically like a dry cooler, which you can basically put something like that on the roof and reject heat to the ambient environment, basically, and you do that kind of most of the year to offset your energy and the cooling energy that would be occurring during the summertime. So there are strategies if that was to occur. So it's not fixed by any means. But again, the borehole field would still be operational and still be fine. So a leak is really the only thing that can happen in a borehole field that would make it not function.
And we've planned for that possibility, which is extremely, extremely, extremely unlikely, but anticipated that by anticipating the possibility of if you needed to connect a temporary system to the building externally. So we've, planned for that.
Yep, yeah, but because it's a heat pump system, it operates at a very mild water temperature, generally between 40 and 80 degrees. And it's pretty simple to install a temporary boiler or temporary cooler of some sort if that was ever needed in an extreme emergency condition. You're basically just maintaining the combined heat pump loop within that temperature range. And then you would then be providing heat or cooling to the entire facility.
So what's, just hypothetical, what's the potential disruptor 5 years from now that says you made the wrong choice? Is there anything on the
Wrong choice
horizon?
of what? The system or?
The system, yeah. I mean, is there anything on the horizon that we should be like, is this a better choice? Or is this it right now?
We
don't think so.
Okay.
We don't think so.
You mean in terms of future
Energy
technology that's
consumption,
coming?
geothermal systems,
Future technology, yeah. I mean, yeah.
They outperform everything.
And I'll
the
just,
water source heat pump based system, it fits really well with an educational facility. Many other types as well, but just the inherent ability for every individual classroom to have independent control, and then the ability for essentially extreme redundancy, because only one classroom is affected by a heat pump failure. We've installed a number of schools with water source heat pump and geothermal systems, going back over 15 years, and they still perform well.
Lynn?
So my question would actually escalate that. Is this still the best course of action if the Inflation Reduction Act incentives aren't here?
Not necessarily. We'd have to see what the that would be the life cycle costs analysis would show that.
So would you like to see that shown in the LCA? So with Inflation Reduction Act and without, because remember, as we've discussed it, the Inflation Reduction Act is applied after the fact. We have to complete it and then apply, and then you get it. It's not theoretically competitive. I understand your point, which is under this administration, if they eliminate all of that, then that's the difference.
Yeah.
And knowing exactly what that amount is and what you might be out if the Trump administration eliminates it would be good to know specifically.
I mean, I would like to see
Oh,
that.
I know,
Yeah.
I would,
Yeah.
for sure.
We have raised that point, with the leadership, something to know. So I think we can work that into the life cycle analysis and take a look at that. Remember, part of the argument for this in comparison is the lifespan of the system and its, durability over 30 years compared to air source heat pumps. It's kind of part of the parcel of it, which was always part of the discussion. But yes, I raised that point too, is that the IRA was part of the conversation, so. It helps a lot that they're optimizing the system and bringing down the scope of cost, and I hope we'll see that in the cost estimate as well.
Any other questions for the engineers, or?
I mean, not for the engineers, but maybe this, related to that question is, has any of the factors driving the estimate changed given the rising costs of raw materials, steel, other construction materials? Is that going to change?
We'll find out at the reconciliation.
Yeah.
That's a really great question.
Yeah.
Yeah.
So let's continue that conversation, but I don't want to keep them on if we don't need
Yeah,
to.
no, I
Is there
think-
any other questions for the engineers on the system? All right, cool.
Can we get CEUs for tonight?
So we'll find that out.
I guess I did.
Oh, go ahead.
I did want to mention one other thing. You were talking about alternatives. You can have a water surface heat pump system without a bore field, where you would just have a boiler and a cooling tower. That can often be a good alternative if you don't care about carbon pollution or EUI or energy consumption. Because if gas is really cheap, then maybe that is the best economic decision. But I don't think this project would necessarily want that. I just wanted to throw that out there.
No, I appreciate that. I think from a town perspective, trying to convince anybody to pay for a gas-fired system is not going to go over well. So I think what you're proposing is
We have
good,
a
unless it
by-
was
We
sick.
have a bylaw on that, too.
Yeah. Oh, do we?
Yeah, didn't that go through? It has to be green. We have to look at it at least.
Yeah, it was a resolution, essentially.
Oh, that's what I
Yeah.
thought.
So, but thanks for that information. That's
And one
great.
reminder on that,
Yeah.
that we have been pursuing the green incentive points from MSBA, which aligns you with the specialized opt-in code, which is the one that is very difficult to do gas with. Okay.
So I had a question along like Marty's, and I'm sure you said reconciliation, but like the windows, those are German windows, I believe.
They are.
So
Tariffs.
I'm not even worried about tariffs. I'm worried about availability. As we choose materials, I know you guys are choosing great materials, but it's also based upon availability too. Is that how or are you just
Well,
saying
that
this is the
window
optimum and
That
this-
window in particular, we're in close touch with that. A lot of projects are using a particular brand of window. I don't want to mention because I feel like that would be somehow wrong proprietary-wise. But there is a window that fits the current stretch code expectations, and you see a lot of buildings using it. We've used it, and availability's been a problem. So we started experimenting with this company because the performance was better. And the window in particular, he's talking about the 79N, is a thermally broken aluminum clad window with a pretty high performance, and we've been working with that company. We actually just installed it on our own building because and so we checked on that issue of delivery prior to even entering it as a basis of design.
Okay.
And we also compared it to the window that everybody's using that is harder to get. And then I think it is a good question about tariffs. We would probably have to really, I think a lot of these windows are coming, at least triple pane windows are typically coming from Europe. There are not many American suppliers yet, but it is possible to run this model with a lower performance value and a lower baseline cost and see what the impact of that's going to be over time. It's almost like a life cycle analysis just of that decision, because that's precisely why we're putting it on the table now while we're doing the cost-benefit analysis and getting costing information on some of these options.
We just received filed sub-bids on a project in Northborough, and they came in underneath what the estimators had. The estimators did the estimates prior to any mention of tariffs. The steel prices for structural steel actually came in just about on target, so there was no impact. It was United Steel, so they may have had a reserve stockpile of steel they could manufacture from. What we did see was a big increase in the windows, which are aluminum typically. So, and those have a long lead item. We're seeing, on some cases, they want 33 weeks from the time you ink the contract with them before they're going to be delivered on site and installed. So I think there's a lot of question marks in people's minds as to where are we going to end up in price-wise on aluminum at that point in time,
Yeah.
if anything
Yeah.
differs.
Yeah, and the other option that we could talk about that we are installing is a UPVC window, which doesn't have the same material durability in a sense, but very good thermal performance. And we have used that on a school. We've been seeing a lot more of that, and it may not be as impacted because it's non-aluminum, but it has a different kind of durability issue. So, again, all these are fun times to make these decisions.
I think it's another benefit of the fact that we went for a CM at risk, because as soon as we get them
To
on
be
board,
boom.
because one, they're bidding jobs all the time, so they've got that information. And then two, if there is something that has a very long lead time, we can try and finalize that early and actually get that in the works before we're totally done with our documentation.
And then the other thing is Monday, Tuesday, I spent both days at Mass Building Trades. And I know the governor signed the executive order on use of PLAs for building projects. Is that going to affect this project in the bid process?
PLAs.
Price labor agreement is,
Yeah.
basically, we're required to use union contract in
Correct.
an open shop. basically.
Which, yeah, I mean, I know we use prevailing wage anyways, but yeah, I mean, I don't know, like, is there any economic impact on this project?
I would think you'd be more worried about tariffs right now than I would
Okay.
with PLAs.
Good to know.
At least we can calculate what a PLA is going to do to the job. Right now, has anybody's guess what the tariffs is going to do?
Yeah.
And not to say, I mean, I fully support unions, so just so you know. But I just want to make sure I know the impact for the town. All right. Is there anything else? Any questions? If not, I would.
Motion to adjourn?
Then so moved. Is there a second motion, second. Call for roll call. Lynn?
Yes.
Armin, yes. Marty?
Yes.
Nicole?
Yes.
And Josh?
Yes.
And David?
Yes.
All right, we are adjourned. Thank you.
Thank you.